Hello, welcome again to another video. In this video, we are going to find the magnitude of a vector in three-dimensional spaces. There are some other synonyms you may see in different textbooks for the word magnitude, as norm and sometimes as the length of a vector. They're all the same thing at the end of the day. Let's just first of all review the Pythagorean theorem. I do have a full video on that. You can just check it just to refresh your memory. But the idea of the Pythagorean theorem just as a fundamental geometric rule, which states for any right triangle, which is like, it says that the square of the hypotenuse, this is the hypotenuse, let's name it C, and the other sides, let's just name it A and B. It says that the square of the hypotenuse equals the sum of the squares of the other sides. So C squared equals to A squared plus B squared. This is about Pythagorean theorem. It's really obvious in two-dimensional because this is like, assume that this is the xy plane. So the vector C, which is the hypotenuse, just locates on this page. So it's onto this page. And finding the magnitude of this vector is really easy and straightforward. The reason is just it has x and y coordinates, so we can do it with the Pythagorean theorem itself. But as we go to higher dimensions, things going to be a little bit complicated. Not really complicated, but we have to use our imagination to understand what's going on here and there. The reason is just, in addition to width and length, it's going to have height. It's going to be pointing out of the page. So yeah, so it's going to have three different coordinates, x and y and z, right? Let me just try to show you what I mean by that. So if you just have a cube, so the vector in three-dimensional space, it means just assume that cube, the vector going to be pointing into that cube, like somewhere, not on the surface, but into the cube. So that's the whole idea about three-dimension and three-dimensional spaces. Let's say that this is the cube, so the vector, let's say the vector v pointing out here, we name it v. So this vector has x and y and also z coordinates. We assume that this is the z-axis and this is like the x-axis and this is the y-axis, right? Okay, now how can we find the magnitude of this vector? The thing is, let's just forget that this has height. We assume that this is just located on the plane, xy plane, on a flat surface. So we assume that this does not have height. So we're gonna project it on the xy plane, which is this plane right here. This is the xy plane, which is this plane right here on the bottom. So we're gonna project it on this plane right here. So if I just project this into the xy plane, I'm going to get something like this. So this is the vector, like we name it u, and u is the projection of the vector v on the xy plane. So this vector just has the same x and y coordinates as the vector v, but with zero height. So we assume that the z coordinate is 0, so it does not have height. It's just located on the flat surface or the xy plane, right? This one right here. The interesting thing about the vector u, which is like the projection of the vector v on the xy plane, is that we know how to find that. How? We just explained the Pythagorean theorem. So let's see it. So this has x and y coordinates right here. So this value right here is just, let me show you just a second. I didn't want to draw a circle. I just wanted a line right here. So this represents the y value, and this is perhaps the x value right here, because this is parallel to the x-axis, so this is going to show me the x value of this one, and this forms a right triangle. With the hypotenuse, we know how to find the hypotenuse, so the length or the magnitude or the norm of the vector u itself going to be found just by the square root of x squared plus y squared, like this one. But okay, now the vector u it's located on this plane, the xy plane. Now, by just bringing this or raising this upward, we're gonna give it height. So it's going to have the same x and y coordinates, but with height. So it's going to be pointing upward. So now, this guy right here, which I just showed it as the green line, this is going to be perpendicular to the plane x and y right here, because this was the plane and the vector u was on this plane. So now by bringing it up, the height is going to be perpendicular, so the z-axis is just perpendicular to the xy plane right here. So this is perpendicular to the xy plane. So now I formed another right triangle, right, with the hypotenuse v. So if I want to find v is what? V is the square root of this guy right here. What is this guy? This is just the height, or the z coordinate, right? So it's going to be z squared plus this guy right here. What is this? This is the same as the magnitude of u. So the magnitude of u squared. Okay, let's just rewrite it again. So the magnitude of v going to be z squared. Now we have to substitute this guy into here. So now it's going to be the square root of x squared plus y squared. Again, is squared. Now we know that this squared cancels out with the square root. So at the end of the day, I'm going to have magnitude of v going to be the square root of z squared plus x squared plus y squared. If I want to organize it much better, I can say the magnitude of v is equal to x squared plus y squared plus z squared. Here you go. Now we prove the formula to find the magnitude or the norm of the vector in three-dimensional spaces. Now let's see an example. The example just says that find the norm or the magnitude of a vector in 3D. So norm of the vector v, of course in three-dimensional space, as -3, 2, and let's say 1, of course in R3, three-dimensional space. Okay. The magnitude of v going to be the square root of -3 squared plus 2 squared plus 1 squared. Sorry, not cubed. This is squared. It's going to be the square root of 9 plus 4 plus 1. It's going to give me the square root of 14. Here you go. And now we can just use the same idea here and apply it to R4, R5, and higher dimensions. So this is pretty much about this one, and yeah, it was really straightforward. I hope you liked it. Let me know if you have other topics to cover them up, and have a good day.